You guys watch The Office?
Yes, I do.
You do? Okay, sweet. Here we go.
So hello guys, welcome back to the video. This is Rituraj and Wire and today we are going to do electric dipole. So जैसे कि आपने थंबनेल में पढ़ा होगा कि what is electric dipole? Two dipoles and one story. So basically देखिए अगर dipole का बात करें so two charges equal and opposite, okay, and placed together. That's it. That is what we call an electric dipole. दो opposite charges जो कि एक साथ placed हैं, ठीक है? That's the electric dipole. And just think about that this particular dipole give rise to how salt dissolved to water, how our DNAs are formed. Okay, basically CO2 भी जो हम लोग जो breathe out करते हैं वो भी एक टाइम पे जो कि नॉन डाइपोल होता है वो भी डाइपोल बनता है जब वो इलेक्ट्रिक फील्ड में आता है. So this simple equation forms I can say a base to different types of story. Okay, so yeah. बेसिकली मेजर ऑफ द वीडियोस में क्या करते हैं कि इलेक्ट्रिक डाइपोल, इक्वेटोरियल एक्सिस एंड एक्सियल एक्सिस एंड ये डिफरेंट टाइप्स ऑफ एनर्जी जो होते हैं इनको हर एक टॉपिक को अलग अलग चार तरह के टॉपिक में इन लोग बांट के पढ़ते हैं. सो दैट इज नॉट द केस. एक्चुअली ये सब एक दूसरे से इंटरकनेक्टेड है एंड अगर इसको हम लोग एक स्टोरी की तरह पढ़ते हैं तो यू कैन गेट दैट आपको एक सीक्वेंस फॉर्म होगा, ठीक है, आपको एक अंडरस्टैंडिंग बिल्ड होगा. आप बेसिकली इसको मेमोराइज नहीं करेंगे मेरे साथ, आप इसको यहाँ पे लॉजिक से समझेंगे कि यहाँ पे क्या हो रहा है. ओके, सो या लेट्स बिगिन विद द वीडियो. सबसे पहला टॉपिक, व्हाट अ डाइपोल रियली इज. जैसे कि मैंने बताया, टू इक्वल एंड अपोजिट चार्जेस प्लेस्ड टुगेदर and the rest is what the world sees. So two equal and opposite charges plus and q minus separated by a small distance 2a, that is a constant, that is physically but the consequences are profound. Okay, जैसे कि मैंने बताया, why does this configuration matter so much in the nature? Because almost every molecule in universe is a dipole or can become one. Like मैंने आपको CO2 का example दिया. So water H2O is a permanent dipole. Why water is all salts? So why it has surface tension? Why life exists? So CO2 in your breath is non-polar normally but becomes a dipole in an electric field. So every electric material, dielectric material you put in a capacitor works because of a dipole. So basically जो non-dipole भी होता है, अगर आप उनको एक कैपेसिटर के अंदर डालते हैं जो कि पहले से एक नेगेटिव और एक पॉजिटिव प्लेट के साथ होता है तो वो उनके अंदर भी इंड्यूस कर देता है डाइपोल को. सो इसको तो हम लोग पहले भी समझ चुके हैं और आगे भी समझेंगे जब हम लोग डाइलेक्ट्रिक को समझेंगे. सो अंडरस्टैंडिंग द डाइपोल इज अंडरस्टैंडिंग द मैटर एट द मॉलिक्यूलर लेवल. ओके, सो अगर हम लोग बोलेंगे कि मॉलिक्यूलर लेवल में बस केमिकल थिंग्स होते हैं, सो नो, एक्चुअली वो केमिकल थिंग्स रिजल्ट किसको करते हैं? फिजिकल थिंग्स को. सो वी नीड टू अंडरस्टैंड एंड मेक अ कनेक्शन बिटवीन दिस टू थिंग्स टू गेट अवर कॉन्सेप्ट रियली क्लियर. Okay, next the dipole moment direction matters. So yeah, P equals to Q into 2A. That is the common equation that we use for the momentum of a or magnitude of a dipole. So magnitude equals to P equals to Q into 2A, unit is centimeter, and direction from minus Q to plus Q. This is the convention against the electric force direction from negative to positive. Okay, so this is the simple form or the equation that we will use to derive all the other equations. Okay, so direction convention that confuses students. So remember the dipole moment arrows point from where the field lines end minus q to where they start plus q. So they start from plus q and they get to they start from minus q and they get to plus q. What is the natural flow of current? The natural flow of current defined as that something that has nothing wants to go to something that has something. Okay, so here minus q is nothing and plus q is something. The charge want to goes from minus q to the plus q charge. So it points in the direction a positive charge would want to travel inside the dipole from minus to plus, driven by the internal chemical mechanical force holding the charges apart. Okay. The next thing, layer 2, the geometry, two special lines. Every dipole has two special lines that defines its symmetry. The axial line, the line that passes through both the charges, extending beyond them in both directions, also called the end-on position. Okay, and the equatorial line, the perpendicular bisector of the dipole passing through the midpoint at 90 degree, also called the broadside on position. If I say you in an example in a practical way, so just imagine you are on a road. Okay, your friend is minus q, you are plus q, and you are apart from a distance of plus 2a. And from your position there is a second point on the straight road somewhat ahead, and that is called as the P, and from that position we called as the axial dipole. Both you and your friend is dipole, and the point P is where you will find the axial dipole. And just imagine that the straight line has a bisector right at the 90-degree angle from where your friend and you stand. Okay, or the equally bisect. It means the bisector means that it equally bisect each other. So at that point, the bisector road that is being like this is your road, and this is the point where the bisector is being formed. So this point here is called as plus Q, and this is the equatorial position. If I show you in the figure now, so yeah, this is the, look at, this is the straight road, here is the P, there is your friend, there is you, and then it is the bisector line that is called as the plus Q. So axial end on E equals to 2 kp by r cube and V equals to kp r square is positive in the axial one. Okay. And on equatorial run, broad side E equals to kp r cube, opposite to P, V equals to 0 always. Now don't panic right now. I will show you how this derivation is came out and how it is being formed. Okay. So yeah, let's just move on to the part. Yeah, the axial field full derivation. So point P is on the axial line at a distance r from the center O. Charges are at distance r minus a and r plus a from P. So where does this r minus a and r plus a comes from? So basically, this was the diagram. If you look at here, minus q, from minus q to plus q, the distance is actually r, and from r to P the distance is a. So basically, if we talk about the distance of P from the center O, the origin, where it is getting bisected. So from the O to P, the distance is A. For finding the distance between a positive plus P, we need to find the distance as R. From here, R to A, R plus A. Okay, this distance and then the final distance, R plus A for minus Q. And then for plus Q, we have R minus A because half of the R has been covered by plus Q. And the rest of the half is getting minus by A. So R minus A. Oh, sorry. R minus A. Yeah, R minus A. So this is the distance in axial position. So we have here KQ by R minus A ka whole square and along plus X away from the dipole. So for minus Q, we have KQ by R plus A ka whole square along minus X towards dipole. So finally, we get the equation if E plus is greater than E negative. Of course it is. So net field in plus X direction same as P, E axial equals to A plus minus E equals to KQ 1 by R minus A ka whole square minus 1 by R plus A ka whole square. And we have here the final equation as KQ R plus A ka whole square minus R minus A ka whole square by R square minus A square by whole square. Okay, so it get driven down to, simplified down to KQ dot 4AR from the equation, and sorry. Yeah, 2k q dot 2a by r square minus a square by whole square. So we get 2kpr r square minus a square and whole square. So there is some shortcut here. So you need to understand the formulas from before the video also. So you can visit my old videos also. I don't think you need so, because you might know something before starting this particular topic. Okay, so for short dipole, when r is much greater than a, means the distance between both the dipoles are much greater than the distance between the points they have. So in that case, we have the equation E axial equals to 2kp by r cube, direction along P. Okay. Now let's, this was the equation of axial line. I hope so it is clear to you. Let's move on to the equatorial position. So equatorial field full derivation. So point K on the equatorial line at distance r from the center O, both charges are at equal direction, root under r square plus a square from Q. So first of all, take some break and understand where does this root under r square plus a square comes from. Okay, you directly cannot assume this. So basically, if you look at the equation we have here, in equatorial position, we have the point plus Q that is being perpendicular to the line that is being formed between minus Q and plus Q, means the R. So for this point, you know right angle triangle equation. So we have Pythagoras theorem, and what does the Pythagoras tells us about the the hypotenuse side. For the hypotenuse side, we have this equation as base square plus perpendicular square. So this is basically exactly that only. So r square plus a square, a is the distance between plus Q and the point O. Okay, so r square plus a square, we have the distance here. So directional analysis, this is where the elegance lives. The field from plus Q and minus Q are not along the same line. Draw the geometry. E plus points away from plus Q, upper right towards Q, then continuing E minus point towards minus Q, lower right towards minus Q. So components perpendicular to the dipole axis, the y component, are equal and opposite, so they cancel each other. So component along the dipole axis, the x component that is along minus p direction are equal, they add. Each x component E plus x cos theta, where cos theta equals to a by root under r square plus a square. So E equatorial equals to 2 into kq by r square plus a square into a root under r square plus a square equals to kq a r square plus a square to the power 3 by 2 equals to kp r square plus a square to the power 3 by 2. So this is the equation. Yeah, that was basically equatorial field position, and I hope you all get this. This was simply basic. Don't get on the complexity of this, just practice it by your own. I made you the logic simple for you, and this is all about practice, and this is just a simple equation, axial and equatorial part. Okay, so yeah, let's move on to the layer 5. So in layer 5, we will do the comparison between axial and equatorial position. Right now, before I move on, you might have seen here the field from plus q and minus q are not along the same line. Draw the geometry. And when we draw the geometry, we have component perpendicular to the dipole axis, the y component, are equal and opposite. So they cancel each other. And along the dipole axis, in x component that is minus p direction, they add. So basically, we have here kp r square plus a square to the power 3 by 2, and when it is when the r square is less than a square, the r square is much greater than a square, we have kp by r square. So basically, if you see here, is that kp by r cube, I misspelled it. So yeah, if you see here, we have in axial position, the E is equals to 2 kp by r cube, and in equatorial position, we have kp by r cube. So this is the difference between both of them. Actually, the axial one is 2 times than that of equatorial one. So why exactly 2? Look at the derivation. Axial, both E plus and E minus are along the same line, and their difference gives a net field proportional to 2p. Equatorial, only the components along the axis at the perpendicular component cancel, giving a net field proportional to p. The factor of 2 comes from the geometry. On the axial line, both charges contribute. Constructively, to the net field on the equatorial line, only the half field of each charge contributes, the other half cancel each other. Okay, so yeah, that was the comparison between them. If you understand the equation very well, then you can also understand the comparison very well. Okay, yeah, so some notes here. Axial E is along P and equatorial E is opposite to P. So the reversal is deeply important. If you place a positive charge on the equatorial line, it is pushed opposite to P. If you place it along the axial line, it is pushed along P. So the dipole P pushes the charge in completely opposite direction depending on where they stand. Okay. Yeah, comparison table. I made you the comparison already. So yeah, you might get it. As I said, 2 kp by r cube and kp by r cube. So axial one is 2 times that of equatorial one, and direction of E is along P in axial one and equatorial opposite to P. So potential V is equals to kp by r cube, and equatorial is 0 always. So ratio E axial by E equatorial equals to 2 at same r. Okay. Layer 6, potential due to dipole. So what is the potential due to dipole? So we are basically finding voltage. So since potential is a scalar, this is simpler than the field. At a general point P at distance r from the center, making angle theta with the dipole axis. So kq by r1 plus k minus q by r2. So you might know the potential equation, V equals to kq by r. If you haven't, please watch my video before. I have derived it very well for you. So yeah, V equals to kq by r1 plus k minus q by r2 for both the dipoles. So after the geometry, we get V equals to kp cos theta, that is defining the angle, by r square, simply. Okay, so this is the general formula. It works for any point. The two special cases, axial and equatorial, are just theta equals to 0 degree and theta equals to 90 degree substituted in. So for axial, we have theta equals to 0 degree plus kp by r square, maximum positive. Equatorial 90 degree, 0 always. Axial towards minus q, 180 degree, minus kp by r square, maximum negative. General theta, kp cos theta by r square. Okay. Level 7, dipole in a uniform electric field, torque. So now place the dipole in a uniform external field E. The external field exerts forces on the dipole charges. So force on plus q, why does this force exert on them? So basically that is because of electric field. Okay, and you might know that I've just explained to you in the previous video also, that why electric field exerts a force on the charges that are being placed in it. So force on minus q, F equals to q opposite to E. You don't need to watch that video. You can simply just imagine it using right hand thumb rule. So yeah, right hand thumb rule or left hand thumb rule, or Fleming left hand thumb rule. You might know that before coming to this chapter. This forces are equal, opposite, and separated by a distance. They form a couple. A couple produces torque but not to net force. In a uniform field, the torque tries to align the dipole with the field. Derivation derivation of the torque. Let theta equals to angle between P and E. The perpendicular distance between the two forces is 2a sine theta. So that is the torque between us. T equals to F into 2a into sine theta, QE into 2a sine theta, P into sine theta. P into E equals to P sine theta. So yeah, basically that was all. So net force equals to 0, uniform field equal force, T equals to P sine theta. It is the basic equation. You need to just remember this, tau equals to P sine theta. That is the simple equation that you need to find any dipole uniform that is being put in a uniform electric field, the torque of it, the force is being applied on it. So you can simply find it with this equation. Okay, don't worry, we will have I will give you lots of questions for your homework that you can practice on this particular topic only. If not, I can also attach the PDF in the comment section. You can just access it from there. Yeah, the layer 8, potential energy, the complete picture. So I'm out of breath right now. I'm speaking too very fast right now. So yeah, just give me a second. You can read on the screen. Yeah, work done in rotating dipole from angle theta 1 to theta 2. So dW equals to TA theta. So we are finding the work done. So obviously we know the formula for work done is T into A theta. So P sine theta A theta. So W equals to theta 1 to theta 2. We are integrating the whole formula. So P sine theta A theta, P minus cos theta. So P cos theta 1 minus cos theta 2, taking theta 1 equals to 90 degree as a reference. U equals to 0 at 90 degree. So U equals to minus P cos theta. We have minus P. So potential energy table. So for simply potential energy of a dipole, we have minus PE, minimum aligned most stable lowest energy, plus E maximum anti-aligned most unstable highest energy. The dipole naturally wants to align with the field, minimize energy. If you flip it to 180 degree, you put energy PE into the system, realizing it spins back, converts to PE to key, oscillates. Okay, so that was all about potential energy. Here is the complete formula chart. You can use it for practicing also, and you can just I can say that you can just go through it, check your knowledge about on the topic that I just made you understand. If you still have any doubt, you can just rewatch the video again from the part, or you can just comment me out. I can help you in the comment section. This is the quick concept for the exam. You can just read out the summary. This is the master summary, and for the question part, yeah, here we have the questions. You can use and solve this question. This particular question are some of them are conceptual and some of them are numericals. I will also attach some numericals in the description box that you can use to practice your questions ability. And yeah, that was all. I will meet you in another video. Bye.
And now, folks, it's time to say goodnight. We sincerely appreciate your patronage and hope we've succeeded in bringing you an enjoyable evening of entertainment. Please drive home carefully and come back again soon. Good night.